Today, we're diving into a reading that tends to be overlooked by most technicians while diagnosing and servicing chillers. The evaporator approach. Using this reading will help you diagnose refrigerant charge issues, dirty evaporators, and oil logging in the evaporator. We're going to be going through why it's important, how to take the reading, and design evaporator approaches based on the type of evaporator your chiller has. We're also going to be going through some real-world scenarios on how to use the approach value to diagnose the 3 most common issues related to evaporator approach. Checking the evaporator approach is a must. Without it, diagnosing your chiller becomes a guessing game. Let's get into it. Run your machine at 100% or as close to it as possible with stable load. Take your refrigerant pressure and convert it to its saturated temperature using a PT chart. Next, simply subtract that temperature from the leaving chilled water temperature. Imagine a chiller with 134A in it. The evaporator leaving chilled water temperature is 45 degrees, and the suction pressure is 30 psi. Convert the 30 psi to its saturation temp on the PT chart, then deduct that from the leaving chilled water temp. 30 psi saturated is 35 degrees. Take 45 minus 35 and you get an approach of 10 degrees. If this were a centrifugal chiller with a flooded evaporator, I would immediately be looking to correct this issue. However, if this were a brazed plate style, this would be normal. What you're doing here is essentially checking how well the heat is transferring from the water to the refrigerant. Evaporators have different approach values based on the type, and we're going to break it down for you. All of the following approach values are built on real-world scenarios at the startup and commissioning of chillers. If you can't find the manufacturer's literature, these rules of thumbs will serve you well. Starting with the brazed plate heat exchangers. Brazed plate heat exchangers are a popular choice due to their compact design and high efficiency. This is a very common style evaporator on scroll chillers, and even some screw and reciprocating chillers. Like every other heat exchanger, they work by transferring heat without allowing the 2 mediums to contact each other. The design approach for a brazed plate heat exchanger style evaporator is typically between 6 and 12 degrees Fahrenheit. I would begin to look for possible issues if the approach values reach 16 degrees. We have seen approach values as high as 18 degrees on new machines. That's why the manufacturer's information is so important. Direct expansion tube and shell evaporators. DX tube and shell style evaporators are commonly found on reciprocating and screw chillers. In a DX evaporator, the refrigerant flows inside the tubes and the water flows on the outside of the tubes. You can tell if you have a DX tube and shell evaporator because the refrigerant is fed on the end of the evaporator vessel, and the water typically enters at a 90-degree angle. Similar to the brazed plate heat exchanger, the design approach for a tube and shell evaporator is also between 6 and 12 degrees Fahrenheit. It's essential to remember that these numbers aren't arbitrary. They are the result of careful calculations and design considerations. The approach temperature can tell you a lot about your system's operation. If it's too high, it could indicate issues like too much oil stuck in the evaporator or fouled evaporator tubes, or it might point towards a charge issue. That's why filling out a diagnostic log is so important. It gives you a picture of how the whole machine is operating. Flooded tube and shell evaporators. In a flooded evaporator, the refrigerant flows on the outside of the tubes and the water flows inside the tubes, hence the name. This is very common on almost all centrifugal chillers, as well as some screw machines. You can tell if you have a flooded style evaporator because the expansion valve feeds into the center of the vessel at the bottom. The water on these evaporators typically enter at the ends of the vessel. The design approach for this type of evaporator is quite a bit lower due to the larger refrigerant volume and greater efficiency. With a dual-pass evaporator, the design approach ranges from 0 to 3 degrees Fahrenheit. Anything over 5 degrees would require a shutdown for tube cleaning if all other readings are correct. If a system is low on charge, the evaporator approach will be high. Why? Because there isn't enough refrigerant coming into contact with the water. As a result, the temperature difference will be greater. You will also see this with high suction superheat and high discharge superheat. If a system has too much oil in it, the approach will also be high. Why? The oil will act as an insulator, preventing heat transfer between the refrigerant and the water. As a result, the approach value will be high. On the contrary, the suction superheat will be low, and the discharge superheat will be low. If the evaporator is fouled, it will also cause high approach. Why? It will act similar to having too much oil in the system because the fouling is an insulator. The biggest determining factor will be if someone has added a lot of oil in the past and the current oil level is high, as well as a high subcooling reading. Sometimes when a chiller is low on charge, oil return will reduce, and technicians will mistakenly add oil to the system when they really had a charge problem. These values can change if glycol is added to the system. Glycol lowers the freezing point of the water, and when cold, it contracts and acts as a slight insulator, which can alter the approach. It's always important to consider all the factors at play in your specific system and read the manufacturer's data before making a final determination. We have diagnostic sheets on our website that you can download to help support us with. If you enjoyed this video, please like and subscribe so we can keep producing more content in the future.